Hi guys, welcome to this little video. We're going to have a look at some examples of basically manipulating these things called surds. Now in the OneNote I've given a bit of an explanation about what surds are, but just to take this example here, what surds are basically roots of numbers where the value of this root is meant to be an irrational number. So if we go strictly with the definition of what a surd is, then it's meant to be something that fits this sort of pattern, where A, B and C are rational numbers, but the overall value of this is irrational, and that's simply what a surd is by definition. Now what we're going to have a look at are some questions that ask us to manipulate surds, and we'll see that the kinds of questions we're going to get will involve basically simplification ones like this, and I'll just put over here some other ways that we're going to be manipulating surds will involve these properties of roots, which apply also to rational numbers, not just irrational values. So the square root of a times b underneath there is equal to root a times root b, and the square root of a divided by b is equal to root a over root b. And one other one that we're going to be using quite a bit is if we have a plus b root c, then something called its conjugate, there's a new term for you, is known as a minus b root c, and quite often we're going to be simplifying a surd by multiplying a surd like this by multiplying it with its conjugate. And if you multiply this out, a squared and then a times that one, it's going to be minus ab root c, and then multiplying these together gives positive ab root c, and then this one times this one is going to be minus b squared c. They're going to cancel, and so we're left with a squared minus b squared c, which is a rational value. And this process of multiplying a surd by its conjugate is known as rationalizing the surd. Okay, so let's, bearing all that in mind, we'll come back and use some of this. Let's have a look at a question like this one. So how do we simplify these roots? Well, what we don't want to do is grab the calculator and plug things into that and get some sort of decimal value. That's definitely not what we're wanting to do here. Okay, so what we do want to do when you're asked to simplify these, let's call them surds, okay, even though some of these might be rational, I don't know, but anyway, it doesn't matter, let's call them surds for now. That what we want to do is to basically end up with a simpler root value. So how would we do that? Well, what we need to recognize, and let's take this root 18 as an example, is that that can be thought of as a square number times something else. In this case, 9 times 2. Well, using this particular rule over here, this one, we can think of that as root 9 times root 2, and root 9 is just 3, so we get 3 root 2. And we can do a similar thing with the square root of 32 and the square root of 50. Root 32, well, that's 16 times 2, so once again think of a square number. Okay, that square number times something to equal 32, well, 16 would work, so this simplifies to 4 root 2. The square root of 16 being 4, and root 2 just leaving as root 2. And root 50, what square number can I multiply with something to equal 50? Well, 25 is a square number, so 25 times 2, and that would equal 5 root 2. Okay, and so what we've got there basically now is if we replace all of these with these multiples of root 2, we're going to end up with 3 root 2 plus 4 root 2. I'll just rewrite that a bit tidier. Minus 5 root 2. Okay, well that's going to be 7 root 2, take away 5 root 2 would be 2 root 2. So in questions of this type, what you're basically looking for each time is to rewrite each of these as some sort of multiple of a square number. Okay, and that's, yeah, usually the questions are similar to that. Okay, let's take another one where we might be asked to simply maybe expand things out. Well, I'm just going to move to a new page. So let's insert a new page, and let's take this second example, where this time we simply might be asked to simplify something like this. And this is simply going to be expanding out. So we've got 2 root 7 times itself. Well, that will be 4 times root 7 squared. Now you might already recognize that's simply going to be a 7. I'll leave it like this for now. So we multiplied those two together, and let's now multiply 2 root 7 times this one. So that's going to be equal to positive 6 root 7 root 5, and these two now multiply together, so minus 6 root 5 root 7, and that times that. Okay, that's going to be minus 9 and then root 5 squared. Now what you might have recognized here was that this complex number, or this pair, okay, and here, but basically look like similar to that conjugate idea. Okay, so we've got minus and positive of the same value there, and so we're going to get basically that same kind of simplification going on, because they're definitely going to cancel, and we're left with root 7 times itself is 7, so 7 fours are 28, and root 5 times itself is 5, 9 fives are 45, so we're going to get 28 take away 45. Okay, so what's the difference between those two? It'd be 2 up to 30, 12, 17, so I think negative 17 would be the correct answer there. Yep, that's right. Okay, let's take a look at one other one where we might be asked to simplify, and let's take one where we might be asked to simplify, say, this one here. Now for this one here, okay, we've got to think of, well, what could we possibly have as some sort of base root value that we can simplify each of these ones to. I'm tempted to have a look at the idea of 9 times 3, hoping that 108 and 147 are some sort of multiple of 3. So let me just have a look at that for a moment, which I think is going to work. Okay, so I just pause the video there for a moment just to check a couple of calculations, and okay, sure enough, 147 and 108 are multiples of 3. In fact, 147 is 49 times 3, and 27 is 9 times 3, and 108 is equal to 36 times 3. And once again, what gave away the idea of using 3 was because I could only think of 9 times 3 being 27, so I was going to use some multiple of root 3. Okay, and so these simplify to 7 root 3, the square root of 49 being 7 times root 3, and 9, the square root of that is 3, so this is 3 root 3. And on the bottom we've got the square root of 36 is 6, so 6 root 3. And let's continue with that. So that's going to be 4 root 3 over 6 root 3. Well, they're going to cancel, and the fourth 6 is going to simplify to 2/3. Okay, and one last one. Let's have a look at rationalizing. Okay, so let's say we're asked to rationalize this one. 4 root 5 minus 2 over 3 root 2 minus root 3. Now, to rationalize something means we want a rational number on the denominator, the bottom line here of this numeric actual fraction. So to do that, we're going to use the conjugate of this. So this will be 3 root 2 plus root 3. Same numeric values but opposite sign here. And to keep it equal, we also need to multiply the top by exactly the same amount. So multiplying out the top, we're going to get 12 root 2 root 5 plus 4 root 3 root 5 minus 6 root 2 minus 2 root 3. I think that's done correctly. Let me just go double check. 12 root 2 root 5 plus 4 root 3 root 5, yep, minus 6 root 2 minus 2 root 3. Yeah, I think that's correct. Bottom line, we're going to get 9 times root 2 times itself, so that's going to be 9 times 2 is 18. And the 3 root 2 times positive root 3, I'll just put that in for now, but each time this is going to cancel out, as we'll see in a minute, and that negative root 3 times 3 root 2 will be minus 3 root 3 root 2. Notice these are going to cancel, and root 3 times itself will be minus 3. Now that top line there, can we do anything much with that? We may be able to. This definitely can be written as root 10. That's root 15 if I want to put them together. I don't think we can basically simplify them though. So I'm going to leave them for now. Okay, bottom line, they cancel, and 18 take away 3 is going to be 15. Okay, so I think that will do. Okay, and yeah, I'm just going to leave it at this stage for now. Okay, so there's some examples of typical kinds of questions on manipulating surds. Okay, we'll catch you in class.